All right, let's learn about the volume using the disk method, but this time revolving around other axes that are not just the x and the y axis. The idea of setting it up is the same thing as yesterday. You want to use the pi and then the integral of the radius squared on the inside. The harder part about today's lesson is actually finding what that representative radius is. And one thing that helps that you calculate that a lot is actually just drawing a quick little sketch. I'm not looking for like masterpieces of art or anything like that, just a quick sketch to help you visualize what's going on really truly is the best thing you can do. From that point, from your picture, you identify the radius, set up an integral, and then just solve your integral to get the volume you're looking for. So let's take a look at this very first example here. We are going to have the lines y equals x, y equals 0, and x equals 1. All very simple lines to draw a sketch of. Okay, y equals 2x here. We're going to call that y equals 2x. Y equals 0 is, of course, the x-axis. And let's make this one y equals 1, or x equals 1, sorry. Okay, so pretending I can draw straight lines, we have this triangle-shaped region that we're going to revolve around that x equals 1 thing. If you imagine that triangle spinning, what we're going to end up with as our solid is a cone. Okay, just a right circular cone that you know the volume of using formulas from geometry. So that's a good way of checking your answer when you're done in this case, because it's possible. Our radius, remember, radius is always taken perpendicular to the axis of rotation. So our axis of rotation, that x equals 1 line, is our axis of rotation, and we have that radius right in there that I just drew in yellow. And to find that quantity, we actually end up taking this distance in green and subtracting off this kind of blank space that our solid isn't taking up that I just drew in black. All right, that distance in green is 1 because we know it goes from the y-axis all the way to x equals 1, so that is a distance of 1. The distance in black is a little trickier because it's this distance right in here. So how do we figure out what that is? It actually uses the equation of that line y equals 2x, but we're not talking about an x value. We want some y value, or we want the x value, not the y value, sorry. So I have to solve that equation for x. So that distance is actually 1/2 y using our formula. So my yellow radius here that I actually want to use in my integral is 1 minus 1/2 y. Again, that's the hardest part about this because you already know how to do the integrals from yesterday. So let's set up our integral over here. The volume is going to be pi times the integral. With the vertical axis of revolution, we are using everything in terms of y. So I need some y values. Here we know that y is 0, and here we know that y is 2. So I'm going to integrate from 0 to 2 of my radius squared. All right, this particular integral is not too difficult to integrate by hand, so let's just take a second and do that because it sounds like a lot of fun today. Foiling this out, we get 1 minus y plus 1/4 y squared. And then when we integrate, we will have y minus 1/2 y squared plus 1/12 y cubed from 0 to 2. So plugging in 2, 2 minus half of 4 is 2, plus 8 over 12. So 8 pi over 12, which simplifies to 2 pi over 3 as our volume of that cone. And if, because we know it's a cone, if you use that volume formula, for that of a cone, this particular cone, you will also get 2 pi over 3. So it's a good way of checking, since we can in this case. Okay, well, let's look at one more, just to make sure we've got it. Again, you want to start by sketching a picture. So we have a parabola and a line. The parabola is a fairly simple one, y equals x squared. So sketch that. And then the line y equals 2. Let's call this y equals 2. And the region I'm looking at revolving is this section right in there. So it's kind of going to be another one of those egg shapes similar to the notes from yesterday. Radius. Oops, I forgot to draw that we're revolving around that line y equals 2. Radius taken perpendicular to the axis of rotation. So from axis of rotation out to the graph that we are, or the edge of our solid. Okay, so again, we have to do some subtracting in this one. We have this whole distance here in green that we know is 2. And we have this distance that needs to be subtracted off, which we know is x squared. So our radius ends up being 2 minus x squared. So our volume, pi integral 2 minus x squared squared. And the last piece of information that I'm missing are these limits of integration over here. Now I know that my y coordinate has to be 2 in both of those locations. So if y is 2, x has to be square root of 2 and negative square root of 2 if we just do a little bit of simple algebra there. So there's our integral. And this one's totally doable by hand, but because of the radicals, it does get a little messy in there. So I just went ahead and typed all of that into my calculator and got an approximation of 18.956. And if we're into labeling, units cubed, because we're talking about volume. Okay, label's not super important until they start to give us units up in the actual problem, but if you want to, it's units cubed. Let me know if you have any questions over this material, either tomorrow or throughout the weekend, and hopefully we'll see you soon. Have a great day.